Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about the applications of the auxiliary planes to evaluate the true shape and size of an inclined section surface of a solid. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with a solid which has been sectioned by an auxiliary inclined plane, and this section cutting plane, so it leaves a surface A at the top of the solid. So this is the remaining portion of the solid that we are able to obtain after the sectioning. Now we are required to obtain the true shape of the sectioned surface of the solid using the auxiliary plane method. Now in order to evaluate the true shape and the size of the surface A, we have been provided with the orthographic projections of the solid, that is the front view and the top view projections of the solid. They are available with us, and looking at these orthographic projections, we evaluate that the front view of the section solid provides us with the edge view of the section surface. So here we have the section surface as the surface A. So the edge view of the section surface A is available with us in the front view orthographic projection, whereas the top view of the section surface, it is being projected onto the horizontal plane as a foreshortened view or a reduced view. And the reason for obtaining the reduced view onto the horizontal plane is because this particular section surface, it happens to be inclined to the horizontal plane. So that is why, due to this inclination, we are not able to obtain the true shape of the section surface onto the horizontal plane. So what we are required to do, we are required to draw another auxiliary inclined plane parallel to the section surface of the solid. The projections of this surface onto the auxiliary inclined plane will be providing us with the true shape of the cut section of the solid in the auxiliary plane, right? So the projections which will be obtained on the auxiliary inclined plane will be called as auxiliary plane. So the auxiliary plane will be providing us with the true shape and the size of the inclined surface A over here. Now let us read out the statement. Now the statement reads as: the object shown in the figure has got an inclined surface A observed as an edge view in the front view. So this is the section surface A which is appearing as an edge view in the front view orthographic projection. Now we are required to draw the front view, the top view and the partial auxiliary view showing the true size and shape of this inclined surface available as face A into this isometric projection. Now we have been provided with the orthographic projections. Now let us start with the construction of the orthographic projections of the solid. So step number 1, we are required to draw the XY reference line, and then we know that the front vertical edge of the solid, it is at a height of 20 millimeter from the base. So this edge, it corresponds to this front edge of the solid over here, right? So this height we have been provided equal to 20 millimeter. So this height of the front edge of the solid I have marked as 20 millimeter. So this is the front edge of the solid corresponding to this vertical edge of the solid over here. So we know that the width of the solid, it happens to be 40 millimeter. So this is the width of the solid over here in the orthographic projections, and in the isometric projections this will be the width of the solid. Now let me draw the width of the solid. It is equal to 40 millimeter. Once I draw this width of the solid, I know that the rear edge of the solid, it is a longer edge and it is having height is equal to 58 millimeter. So this is the rear end of the solid having vertical edge height is equal to 58 millimeter. Now I am going to mark this height equal to 58, and correspondingly I am going to draw the rear edge of the solid at a distance of 40 millimeter from the front edge of the solid. Having drawn the front edge and the rear edge, now this inclined surface of the solid which is appearing to me as an edge view. So this will be obtained. So this is the edge view of the section surface of the solid. So this is the section surface of the solid. It appears as an edge view in the front view orthographic projection. And having drawn this edge view, now I also know that the width of this portion of the solid, it is equal to 20 millimeter. So this portion of the solid measures 20 millimeter. So I am going to mark this distance of 20 millimeter, and whatever vertical height of this middle edge is there, so this corresponding height of the middle edge, it will be obtained as per the construction over here, right? So this edge height is not provided to us, so this will be available to us as per the construction. So this completes the orthographic front view projections of the solid. Now we need to draw the top view projections of this particular cut section over here. So this is the cut section which is available with us in the isometric projection. Now the top view projections we need to obtain. So we need to draw three projection lines from first edge, second edge and the rear edge. So this is the front edge, this is the rear edge, this is the intermediate edge, that is this one. We know that the top view projections, they are going to start at a distance of 24 millimeter from the vertical plane. So this is the distance of the top view projection from the vertical plane. So this distance we are going to mark as 24 millimeter. So once we mark this distance, so this is the edge of the solid which we are going to draw over here, and the edge length, it is equal to 40 millimeter. So now this edge length we have drawn equal to 40 millimeter, right? So once we draw this edge length over here, so this is the starting point of this particular top view projection over here in the top view. Now this distance, it is provided to us equal to 20 millimeter. So this distance, it is equal to 20 millimeter. This distance, it is equal to 20 millimeter, which is the depth of the solid, and the depth of the solid corresponding to section number 1, it is equal to 20 millimeter, while the total depth of the solid happens to be 40 millimeter. So total depth of the solid, it happens to be 40 millimeter. So this is the total depth of the solid. So I have drawn the depth corresponding to the first element, that is the first web over here. So this web thickness has been provided to us as 20 millimeter, while the total depth of the solid happens to be 40 millimeter. So corresponding to this 40 millimeter, so we have drawn a projection line over here, and then we can complete the edge corresponding to this 20 millimeter depth of solid over here. That is, this edge has been drawn over here, then there is the vertical edge over here as it appears like this, and finally we have drawn this edge. So this way the front view and the top view projections of the solid, they have been completed. Now let us complete the front view projections as darkened ones as they are appearing to an observer. So this is the front view projection as they were provided to us. Next, we need to complete the top view projections of the solid so that we are able to see that the section surface, it appears as an edge view in the front view, and the section surface appears as a foreshortened view or a reduced view or the apparent shape view in the top view projections over there onto the horizontal plane. Now let us mark the different points of this particular cut section. So we have shaded the cut section corresponding to which the true shape needs to be obtained. This is the section surface which has been shown over here. Now we are going to mark different points of this particular top view so that we can identify these points in the auxiliary plan which will be obtained on the auxiliary inclined plane, which will be drawn parallel to this edge view of the cut section. Now we have marked these points as point 1, point 2, point 3, point 4, point 5, point 6. So the 6 points we have marked in the top view over here. Now all these 6 points we are going to carry forward and mark them in the front view edge view over here. So we are looking from this side. So looking from this side, this point will be 6 dash and 1 dash. So projections corresponding to point 6 and 1, it will be 6 dash and 1 dash over here. Then corresponding to 4 and 5 points over here, we get the front view projections as 4 dash and 5 dash. And finally, corresponding to these 2 points 3 and 2, we have obtained the front view projections as 3 dash and 2 dash. So the front view edge view of the section surface has been obtained, and the top view corresponding to the section surface has also been obtained. Now we need to draw an auxiliary inclined plane x1 y1 parallel to the sectioned cut surface over here. And once we draw an auxiliary inclined plane parallel to this cut section edge view, now the perpendicular projectors from 6 dash 1 dash, 4 dash 5 dash and 3 dash 2 dash will be drawn onto the auxiliary inclined plane, so that the corresponding auxiliary plan view can be obtained on this auxiliary inclined plane. In order to draw this auxiliary plan, now we need to evaluate these distances. So the distance of point 1 from the vertical plane happens to be 24 millimeter. Distance of point 2 from the vertical plane happens to be 24 millimeter. Distance of point 3 from the vertical plane, it is equal to 64 millimeter. Then distance of point 4 from the vertical plane happens to be 64 millimeter. Similarly, the distance of point 5, which is appearing in the top view from the vertical plane, this happens to be 44 millimeter. And finally, the distance of point 6 from the vertical plane happens to be once again 44 millimeter. We have evaluated the distances of all these points over here from the vertical plane. Now these points we are going to mark onto the corresponding projector lines in the auxiliary plan view, which will be obtained on AIP. Now another thing, we know that point 1 and point 2, they are lying in front of the vertical plane at a distance of 24 millimeter. So we are going to mark these 2 points onto the auxiliary plan view. So point 1 will be lying over here, whereas the projections of the point 2 on the auxiliary plan will be lying over here. So let us mark the distance of 24 millimeter ahead of this auxiliary inclined plane. So the distance of point 1 and point 2 will be 24 millimeter from the auxiliary inclined plane. So this point, which is lying over here onto the projection line corresponding to the point 1 dash, will give us the projection of point 1 1 over here. Similarly, this point, which is obtained at a distance of 24 millimeter from the AIP, as it is lying on the projection line corresponding to the point 2 dash over here. So this will provide us the projections of the point 2 1 onto the auxiliary plan view. Then we also know that the distance of point 5 and point 6 from the vertical plane, it happens to be 44 millimeter. That is another 20 millimeter ahead of the points 1 and 2. We are going to obtain the points 5 and 6 onto the projection lines of 5 dash and the projection line corresponding to point 6 dash over here. So we have marked this distance equal to 20 millimeter. And now once we draw a projection line over here, we obtain the projections of the points 6 and 5 over here. So the projection corresponding to the point 6, it is going to be termed as 0.61, and the projection of the point 5 in the auxiliary plan will be termed as 0.51 over here. And finally, we know that the distances of the points 3 and 4 from the vertical plane, they happen to be 64 millimeter. So we are going to mark this distance of 64 millimeter from the auxiliary inclined plane. So this distance we have marked over here, and once we mark this distance, another projection line we are going to get onto the auxiliary plan view. And now the projection of point 4 will be obtained on the projection line corresponding to the point 4 dash at a distance of 64 millimeter from the AIP. So this distance happens to be 64 millimeter from the auxiliary inclined plane. So here we get projection of point 4 as 4, 1. Similarly, the projection of point 3 onto the auxiliary plan view will be called 3, 1. So this point 3, 1, it is obtained at a distance of 64 millimeter from the auxiliary inclined plane. In this way, we are able to identify the projections of all the 6 points corresponding to the sectioned cut surface over here, right? So this section cut surface points, they have been identified and located onto the auxiliary plan view. This provides us with the complete construction regarding the true shape of this section cut surface, which has been marked as surface A over here into the isometric projection. Now this surface, as it is obtained in the auxiliary plan view onto the auxiliary inclined plane, this is going to reveal the true shape of the section surface over here, because we had drawn this auxiliary inclined plane parallel to the edge view of the sectioned cut surface of the solid. And now we can do the shading of this surface as well, and we can mark this surface as auxiliary plan. So this is the complete procedure regarding the evaluation of the true shape of the sectioned cut surface, which is an inclined surface, and we are not able to see the true shape of the surface either in the front view or in the top view over here, even in the orthographic projection. So here we have verified that this true shape of the cut section, this is bigger than the apparent shape of the cut section which was observed in the top view, which was viewed onto the horizontal plane. So I hope that through this discussion you would have understood about the mechanism to evaluate the true shape and size of this inclined cut surface over here. So this is all for today. So we'll be continuing with discussion regarding few more cases of the applications of the auxiliary planes in the coming lectures. So thank you very much. Thanks a lot.